Okay, now you're very welcome to Applied Maths Made Easy. We're going to look at 2006 question 10b here. The acceleration of a particle moves horizontally in a straight line is 1 over x to the power 3 away from a fixed point O where x is its distance from O. Okay, the particle starts from rest at x equal to 1. Calculate the velocity of the particle when x equals 4 over 3, the time that it takes the particle to reach a point 2 meters from O. Okay, now, so we're trying to find a way in here, right? We need a kind of to kick it off. So we see the acceleration is 1 over x to the power 3. So we were bringing that fellow up anyway. So we're saying acceleration is going to be equal to x to the power minus 3. So remember then that we have our representations for acceleration, okay, and you're asked to find the velocity of the particle when x is this thing, right? So let's have a look at it and see. Okay, now linking back into the question at all times, right? So here's this thing that's been, hopefully I'm slowly brainwashing you into it, so applying this thing, right? So we have here then, look, there's your velocity, right? Change your distance with respect to time. So now we have acceleration, which is this. They're telling you in the question that its acceleration is 1 over x to the power 3. Bring it up, so it's going to be x to the power minus 3. Okay, now we're getting it primed for integration then. So, you know, you're making good, tidying it up, and sort of making sense of it. And then we're doing the maths. Okay, but getting to that stage, it can be tricky. So as I said, all it is practice, practice, practice. Now, calculate the velocity of the particle when x is equal to 4 over 3. Okay, so the question also says the particle starts from rest at x equal to 1. So there's your once upon a time. Once upon a time, the particle starts from rest at x equal to 1. Okay, so it starts from rest, not moving. Calculate the velocity of the particle when x is equal to 4 over 3. Okay, so see what you're doing here. You're asking the almighty integration, please tell me what is the velocity, you know, after it starts a distance of 1 meter, okay, from a fixed point O, and it travels that, right? Now, so again, you can pause the video, give it a go, make sense of it, see do we have what I have matches up to what you have, and that you're in control of the question. Okay, so we bring it up to here. So remember, you know, talk to yourself when you're doing it. Have that mathematical conversation, that maths commentator of what you're doing. Okay, because I keep saying this, the errors that creep in, remember all those little tiny things where the small maths becomes the big maths, chips away at those 300 marks that you're fully capable of achieving. Okay, so looking at all that then, look, so add 1 to the power, divide by the resultant power. So I'm just tidying that up, so just shown and seen hopefully that you know what's going on, the mechanics of integration, if you get me, right? So your minus 3 plus 1 minus 2, submerge it below that the line, so you have that there. Okay, add 1 to the power, divide by resultant power, and put the square brackets around it then. So don't have the integral there anymore. Integration has now done its job, and we're just putting in your upper limits, lower limits. Okay, take your time with it. So I'm putting v in there, and now I'm going to be putting in 4 over 3, okay, into that, and then minus the lower limit, if you get me. All right, now question just doesn't say write it as a fraction or decimal. Put down both. Okay, and maybe to 2 place a decimal, right? See what you get. Okay, now, so working it down, we have it. Okay, so hopefully that is making sense to you. Now, second part, the time that it takes the particle to reach a point 2 meters from O. Calculate the time that it takes the particle to reach a point 2 meters from O. Okay. Now, so again, when you're doing that, look, so the hard work is being done. Okay. So you go back to that point where you had it primed. For integration, you integrated it, and we have this. Okay, the time that it takes the particle to reach a point 2 meters from O. Okay, so looking at that then, so it's a great question where it's, you know, sussing out, do you understand or can you visualize what's happening in this question 10 story? So we just go back here for a second. Look, so it away from a fixed point O where x is the distance from O. The particle starts from rest at x is equal to 1. Okay, x is the distance from O. So the once upon a time, how far is it from O? 1 meter. The time that it takes the particle to reach a point 2 meters from O. So how much further does it have to go to be 2 meters from O? You with me? So link it back in then. So that's why we have these limits then. So the thing has been integrated. Then we put on the maths blinkers and we get down to it and working our way through it. Again, pause at any time, linking back in and see what I have correlates to what you have. All right, so we do all that, upper and lower limits, working our way down. Take your time with it. So if you look at that there now, so you have your minus minus, which is your plus, so you can just kind of, you know, clicking it all together. All right, so your v squared over 2, tidying it all up. Now, again, what we want is you have an equation, like when things are a single fraction, then, you know, it makes life easier in applied maths world. Okay, so I'm multiplying above and below by that, so these guys will have a chat. Okay, so we bring it to the next stage then. So your v squared over 2 brings you down to here. Okay, so your v squared over 2, we have that then. Simplifying it all down, take your time with it. So, and again, watch out, small maths becomes the big maths, so you're saying exactly what you're doing, so division becomes multiplication, so I'm bringing that guy over, tidying it all up, and we have this thing, put a square root around it, and we have its velocity after it travels 1 meter, which coincidentally is 2 meters from that fixed point. Okay, so you're checking in with yourself as you're doing it, right? Now, the time that it takes the particle to reach a point 2 meters from O. So this question's persistent, isn't it? It keeps going. Okay, now, so we look at this fella here. So your velocity then is going to be your ds dt, or in this case, the distance is represented by x. So we have this going on. Notice what I'm doing here as well, right? So the square root, if I bring the square root in there, so the square root of x squared is x, you can have it like that. Okay, now, so let's see, can we get that solved then, right? So we separated all that out as best we can. So you're looking for the time that it takes the particle to reach a point 2 meters from O. Okay, so it is 1 meter from O, and it travels 1 meter. See what I'm doing there? Okay, lower limit is 0, upper limit is t. Okay, now when you're doing this as well, look, so we'll go old school, and this will stand to you in third level as well. You look to the thing that's the most complicated, and we're going to use calculus to detangle it, all right, to see the connection between, you know, all the bits and bobs of it. Okay, so let u equal to x squared minus 1. You're going to say to yourself du dx, and if you remember from previous videos, it's all about u. Okay, what does that mean? If this is the first video you're looking at. So we're going to integration by substitution. So what you're doing is you're going to be substituting in u for all those x's, and you'll know you're right if the x's cancel. Okay, so let's have a look. So u is going to be this x squared minus 1 du dx is 2x, but we want an expression for dx, so bring that guy over there and bring the 2x back. Okay, so we bring that then, and we're looking at the question. So you have your next line will be du is equal to 2x dx, and we go to there then, right? So your du over 2 x dx. Okay, link back in. So this is what we have. It's all about u, and it becomes this, right? So your 1 all over the square root of x squared minus 1. So that's going to be 1 all over the square root of u. Okay. The next thing we have is your x dx, right, can be represented by du over 2. So du over 2, right? Now see what I'm doing as well. So we're getting the number on its own, isolating it, and just going to put it to the left of the integral, and it'll be waiting in the wings then to come back into play. Right over here then, so remember you have your, since there's no letter there, you have t to the power of 0. Okay, so we'll do that, upper and lower limits. There's your half. Again, integration wouldn't be fond of that, so we can manipulate that. So u to the power half, bring it up, u to the power minus a half, and then integrating it, see what you get. Add 1 to the power, divide by the resultant power. We're going to be multiplying it by a half. Add 1 to the power, divide by the resultant power. Okay, so we'll be experts at it now by the end of it. Okay, this might be the first question that you do. Right. So what we're doing then, look, the thing now has been integrated. Do not have the integral there, so it's job done. So what you're doing then is working your way down through it. So you have your upper and lower limits then, right? So where's this guy gone? So the half then will cancel with that. Okay, you have your upper and lower limits, so you put in your 2 to the power half minus 1 to the power half. But remember, yes, what u is. Okay, very easy to sub it in, and then remember that the biggest challenge isn't the applied maths, it's time. So you have to be very careful about any sort of errors that you make. You cannot get back that time. Okay, so yes, so u then is your x squared minus 1. So we plug that in, upper and lower limits. Right, so we do that, tidy it up as we go along. And again, have respect for the calculator. Okay, calculators need things to be simplified. The phrase you've heard me say before, simplicity is the ultimate sophistication. If you keep things simple, fantastic things will happen. So refrain from plugging it all into the calculator. Just do it bit by bit and have transparency there. Okay, so we're putting in your 2 upper limit, lower limit then. Okay, upper and lower limit, so it's just t. Bring it back, looks after itself. You have a quick look to see as you enter the yours sincerely part of the question, the time that it takes the part to reach a point 2 meters from O. Doesn't say decimal, doesn't say fractions, then put down the 2. Okay, and we'll see you again very shortly.